The insert, into, statement is used to add new data to a database table. This allows databases to grow and store meaningful information. This statement can be used in different ways, depending on the source of the data and the structure of the table. In many applications, insert into is used when a user submits data through an interface, such as filling out a form in a web or mobile app. When the user enters their information and clicks submit, the application processes that input and sends an insert into statement to store the data in the database. Another common use is importing data from external sources. Businesses and organizations often need to migrate data from spreadsheets, text files, or other databases. In these cases, bulk insert operations allow large sets of records to be added efficiently. Additionally, data can be inserted from existing tables within the same database. This is useful when archiving records, creating backup copies, or generating reports based on filtered or aggregated data. Regardless of the source, ensuring data integrity is crucial. Database constraints, such as primary keys and foreign keys, help prevent duplicate or inconsistent entries when inserting new records. Let us insert some data. Before we can insert data into a table, we need a database and at least one table to work with. So, let us start by creating a new database and setting up a couple of tables. We begin with the create database statement. Create database. Persons. Once the database is created, the next step is to connect to it. This process varies slightly depending on the database system you are using. In Postgres, the database system I am using, you use the \c database name command to connect, in my case. \c persons. In MySQL or MariaDB, you use the command use persons. For other relational database management systems, the exact command might differ slightly, but the idea remains the same. You need to select the database before working with it. Check the documentation for your specific database system. Now that we are connected to our database, it is time to create two tables. A table is a structured way of organizing data, similar to a spreadsheet, but with much more control, flexibility, and efficiency. Each table consists of columns, also known as fields, and rows, which store the actual data. For this example, we are going to create two tables, names, and ages. The first table, names, will store information about people, specifically their ID, name, and city. The second table, ages, will store their ID and age. Notice that both tables contain the ID column. This is important because it will allow us to establish a relationship between the two tables later. Let us start by creating the names table. Create table, names. ID, integer. Name, variable character 50. City, variable character 50. The ID column is an integer type, meaning it stores whole numbers. The name and city columns use the variable character data type, which allows us to store text with a maximum length of 50 characters. Now, we can create the second table, ages. Create table, ages. ID, integer. Age, integer. Here, the ID column in ages matches the ID column in names. This consistency is important because it ensures that we can later link data from both tables using this common field. The age column is also an integer, as it only needs to store whole numbers. Keeping the same data type for the ID column in both tables is a good practice. It avoids potential issues when working with relationships between tables, such as when performing join operations to combine data. If the data types of linked columns do not match, queries can fail or require extra processing to convert between types, slowing down performance. At this stage, we have successfully set up the structure for storing names and ages in separate tables. The next step will be inserting data into these tables, which we will cover in the next slide. Now that we have our tables set up, let us talk about adding data. In SQL, we use the insert into statement to add new rows to a table. This is one of the most fundamental operations in any database, as data is only useful if we can store it and retrieve it efficiently. The general syntax for inserting data looks like this. Insert into table underscore name. Opening parenthesis, column 1, column 2, etc., closing parenthesis. Values. Opening parenthesis, value 1, value 2, etc., closing parenthesis. Let us break this down step by step. First, table underscore name refers to the table where we want to insert the data into. If we are adding data to our names table, we would use insert into names. If we are inserting data into the ages table, we would use insert into ages. Next, inside the first parenthesis, we list the column names that we are inserting values into. This step is actually optional. If you are inserting data into all columns, you can skip listing them. However, explicitly naming the columns is a good habit, because it makes the command clearer and avoids issues if the table structure changes later. After specifying the columns, we use the values keyword, followed by another set of parentheses containing the actual data. Each value corresponds to a column in the order we listed them. For example, if we are inserting a record into the names table, it might look like this. Insert into names, ID, name, city. Values, 1657, John Doe, Gdansk. Text fields have to be within quotes. Here, 1657 is the ID, John Doe is the name, and Gdansk is the city. Similarly, if we want to add a row to the ages table, we would do insert into ages, ID, age. Values, 1657, 38. The ID remains the same, linking this record to the person in the names table, while 38 is stored as the age. Since insert into is used to add data manually, it is often part of applications that take input from users or import data from other sources. For example, a registration form on a website might use an insert statement to store new user information. A business might import customer records from a spreadsheet into a database. Data could be copied from one table to another using an insert statement combined with a select query. It is important to ensure that the values being inserted match the data types of the columns. If a column expects a number but receives text, the database will return an error. With this, we now understand how to insert data into tables. Now that we have covered how to insert a single row into a table, let us take it a step further and talk about inserting multiple rows at once. This is useful when you need to add a lot of data efficiently without running multiple separate insert into commands. The general syntax looks like this. Insert into table underscore name, column 1, column 2. Values. Value 1a, value 2a, comma. Value 1b, value 2b, comma. Value 1c, value 2c. Notice how we specify the table name and columns once, then provide multiple sets of values inside values. Each row is enclosed in parentheses, and they are separated by commas. The command ends with a semicolon. This method has two big advantages. First, it improves readability. By listing each row on a separate line, it is easier to see what is being inserted. This makes debugging and reviewing data simpler. Second, it is more efficient than inserting rows one by one. When you insert multiple rows at once, the database processes them in a single operation instead of executing multiple separate commands. This reduces processing time, especially when dealing with large data sets. As you can understand, if you need to insert hundreds of rows at once, this format makes it much easier than writing a separate insert into statement for each row. A few things to keep in mind. The number of values in each row must match the number of columns specified. If you list 3 columns, Each row must contain 3 values. The order of values must match the order of columns in the statement. Data types must be correct, numbers should be inserted into numeric columns, and text into text columns. Some database systems may have a limit on the number of rows you can insert in one statement, but for most modern relational databases, inserting multiple rows like this is highly recommended for performance reasons. Now that we understand the insert into statement, let us apply it to the 2 tables we created earlier, names and ages. First, let us insert data into the names table. Insert, into, names, ID, name, values. 1. Alice. 2. Bob. 3. Carol. This command inserts 3 records into the names table. Each row has 2 values. ID, a unique identifier for each person. Name, a text field storing the person's name. Now, let us insert data into the ages table. Insert, into, ages, ID, age, values. 1. 25. 2. 30. 4. 40. Again, we are inserting multiple rows at once, with each row containing an ID and an age. But notice something interesting here, there is an ID mismatch between the 2 tables. In the names table, we have ID 1, 2, and 3. In the ages table, we have ID 1, 2, and 4. This means Alice and Bob have both a name and an age in the database. Carol, who has ID equals 3, does not have an age listed. The person with ID equals 4 has an age of 40, but the name is missing in the names table. This is important, because relational databases work best when the data is properly structured. In a real-world scenario, we would typically ensure that every ID appears in both tables. Now, let us break this down a little further. Why is the ID important? The ID acts as a unique identifier, ensuring that each record is distinct. If we were storing customer data, for example, each customer would have a unique ID to differentiate them from others. Why does the second insert statement include an ID that is not in the names table? This can happen if we are working with separate data sources. Maybe one system is tracking names, while another is tracking ages. If these systems are not fully synchronized, we may end up with missing or unmatched data. What happens if we do not include the column names? If we would write insert, into, names, values, 1, Alice. The database assumes we are inserting values for every column in the table, in the exact order they were created. Since we have an extra column, named city, this statement would fail unless we provided a value for that column. The insert into statement in SQL is important, because it allows us to populate our tables with real data. Understanding how ID work and ensuring data consistency between tables is crucial when working with relational databases. When inserting data into a table, sometimes you might not have a value for every column. So, what happens if you leave a field blank? Let us consider a table named persons with 3 columns, first name, last name, and age. Now, imagine we have data for first name and age, but we do not know the last name. We can insert the record like this. Insert, into, persons, first name, last name, age. Values, John, null, 30. In this case, the last name field is explicitly set to null. This means the database understands that the value is unknown or missing. Why use null? In relational databases, null is a special marker that represents the absence of a value. It does not mean empty or zero, it simply means we do not have data for this field yet. Using null has several implications. If you search for where, last name, equals ... an empty string, you will not find John's record. Instead, you must search using where, last name, is, null. This is because null is not the same as an empty string. If you use average, sum, or count, most databases will ignore null values in calculations. This is important when working with numerical data like sales figures or statistics. Some tables might have constraints that disallow null values. If the last name column was defined as not null, then the database would reject this insertion. If a default value is set for a column, and you do not provide a value, the default will be used instead of null. What if you skip the column altogether? Sometimes, instead of explicitly inserting null, you might omit the column completely. Insert into persons, first name, age. Values, John, 30. If the last name column allows null values, the database will automatically insert null in that field. When should you avoid null? While null is useful, it can sometimes cause complications. When performing joins, if one table has null values in a key column, it might not match records from another table. When filtering data, queries need to handle null explicitly using is, null, or is, not, null. When indexing columns, indexes might be less efficient when there are many null values. Inserting null values can be helpful when dealing with incomplete data, but it is important to understand how they behave. Some databases handle null differently, so always check how your system interprets them. When inserting data into a database, you might wonder if you can simply leave a value blank by writing 2 consecutive commas, like this. Insert into persons, first name, last name, age. Values, John, 40. Will it work? Well, that depends on the database. Most relational database management systems do not allow this syntax. If you try to run this statement, you will most likely get an error. Why? Because the insert into statement expects each column to have a corresponding value. By using 2 consecutive commas, you are essentially skipping a value without telling the database what to do. The proper way to handle missing data. Instead of writing comma comma, you should explicitly indicate missing values using null. So, the correct way to insert this data would be: insert into persons, first name, last name, age. Values, John, null, 40. Why use null? When you specify null, the database stores a special marker indicating that the value is missing or unknown. Null is not a value, it is a state. This is an important distinction. Unlike an empty string, quote, quote, or 0, which are actual values, null represents the absence of data. What happens when you use null? We have seen this in the previous slide. When a column contains null, searches using equals will not work. Instead, you must use is null or is not null in your queries. If you sum up values in a column that includes nulls, the null values are ignored. For example, average, age, will only include non-null values in its calculation. If a column is defined as not null, the database will not allow inserting null. Some databases allow setting a default value, so if null is not provided, the default value is used instead. Using null is the correct and standard way to handle missing values in databases. Leaving empty commas will almost always lead to syntax errors. Get into the habit of using null where data is missing. One powerful variation of the insert into command in SQL is its ability to work with a select statement, allowing you to populate a table with data directly from another table. This approach is especially useful for copying or transferring subsets of data, where you can specify which columns to pull and apply conditions to filter the rows you want. Instead of manually entering values, this method streamlines the process by leveraging existing data, making it an efficient tool for tasks like archiving records, creating summaries, or migrating information between tables in a database. Insert into Table 2. Select, star, from, Table 1. Where, condition. This SQL query inserts data into Table 2 by selecting all columns from Table 1, but only for rows that meet a specific condition. Insert into Table 2, column 1, column 2, column 3. Select, column 1, column 2, column 3. From, table 1. This SQL query follows a common pattern. It starts with insert into, targeting table 2 and specifying column 1, column 2, and column 3. Then, it uses select to pull those same column 1, column 2, and column 3 from table 1, copying data from one table to another. Let us take a look at two more examples. Do not worry about these examples yet, I will explain everything in a later video. This is only to demonstrate insert into with a select statement, and a join. Insert, into, new underscore employees, ID, name, department. Select, employee underscore ID, employee underscore name, department underscore name. From, old underscore employees. Where, department underscore name equals sales. This SQL query inserts data into the new underscore employees table, pulling the employee ID, name, and department name from the old underscore employees table, but only for those in the sales department. Insert, into, employee underscore projects, employee underscore ID, project underscore name, start underscore date. Select, e.employee underscore ID, p.project underscore name, p.start underscore date. From, employees, as, e. Join, projects, as, p, on, e.department underscore ID equals p.department underscore ID, n, p.status equals ongoing. Where, e.hire underscore date greater than 2023-01-01. This SQL query inserts data into the employee underscore projects table, targeting the employee underscore ID, project underscore name, and start underscore date columns. It selects these from the employees table, aliased as E, and the projects table, aliased as P. The from clause joins them on matching department ID, and includes an early filter, with n, p.status equals ongoing, to limit it to active projects. As I mentioned in an earlier video, push as much filtering as you can into the from part, like this status check, to optimize performance, rather than relying on where, which processes later. Then, where e.hire underscore date greater than January 1, 2023 narrows it down to employees hired after January 1, 2023, without losing key data. That wraps up this video on insert into. In the next video, we will dive into select, the basics. I look forward to seeing you there.